Okay, we're going to take a look at surface area. One of the important aspects of surface area in the nuclear business is we again have a lot of heating up water, cooling down lubrication oils, and even heating up lubrication oils and things in the wintertime. So we use heat exchangers. And when it comes to the idea of heat exchangers, material has a certain capacity to transfer heat from one place to another. In a basic heat exchanger, we normally have maybe some sort of cold fluid inside of a tube, and maybe we have a hot fluid running the opposite way on the outside of this round tube. And how much heat gets transferred from the hot fluid to the cold fluid has to do with, well, what's the temperature difference? Well, that's part of it. And what are the materials made out of? We made them the tubes out of plastic or some sort of insulator. That would not be near as good as using copper, like your radiator on your car is made out of copper, so you get a good copper transfers heat really well. But it also has to do with how much surface area is there between the cold and the hot. And basically, the surface area is going to come down to how big is each one of those tubes in the heat exchanger and how many tubes do you have. So what we're looking at here, if we look at the end of the tube and we've got maybe the cold water. Oops, I just grabbed the wrong pen. No, I didn't. The cold water running on the inside down the pipe, and the hot on the outside, your heat transfer is going to be from the hot into the cold. And so again, we're worried about, well, what's the area of this whole tube? Okay, so surface area is going to make a big difference in how well this heat exchanger transfers heat. So a possible problem is maybe we need to build a heat exchanger that will be able to transfer 7.52 times 10 to the 6th BTUs per hour. So that's just a amount of heat that this whole heat exchanger needs to do, about 7.5 million BTUs per hour. And we know the material that we've chosen and the normal difference in temperature that we're going to have through this heat exchanger, that we're only going to be able to transfer 41.2 BTUs per hour of heat per every square inch of heat transfer surface we have. So again, if we take a look at these tubes, it's going to be, well, what's the area all the way around the length and all the way around this tube? What's the area that this tube gives? And then how many tubes are we going to need altogether? So we're going to build this heat exchanger, and the tubes we're going to find out are 10 feet long. So our tubes we're going to have tubes that are 10 feet long. And they're going to be 1 inch in diameter. So probably the easiest thing here is to find out, well, how much surface area would each tube need? Oh, so anyway, I guess I didn't ask you an overall question. I need, what are the minimum number of tubes needed in this heat exchanger? Minimum number of tubes in heat exchanger. HX is my industry abbreviation for heat exchanger. So we're basically looking at the surface area of a cylinder, because a pipe is long and it's round. And so when you're calculating the surface area of a cylinder, what you want